This is Brian Hunt. Today, I'd like to talk to you about making projections. There's an example that Sam Savage uses, Dr. Sam Savage from Stanford University, about below and above projections. It's a relatively simple model. And what I've done is wanted to expand it to show what more could be done with that. We're also going to bring in Metalogs, and then we're going to optimize the order quantity. Let's talk about the basic problem. We have some historical data that's available with an average demand of 100,000. And we need to order a product to meet that demand. And the question is, the decision to make is, what quantity should we order to maximize that profit? It sounds pretty simple. And the first impression would be, well, we order the average demand. Well, let's see what happens when we look at the model. So here's our model. Demand reorder is shown by this 100,000 here in this cell. We can change that. We have a cost of a unit is $30, and we sell it for 40, so a profit of 10. And if we order the average demand on this particular trial, we earn $118,000. That's pretty good. But the average demand is only 98. Well, we thought it was 100, but it actually turns out to be 98.9. And the average profit is 395. So let's see if we can get this on the same screen here. So what if I ordered a little bit more? Let's do 110. And the profit went down. Let's go back. Each time I'm making an enter key, I'm running 1,000 trials. Well, let's try going lower then. Let's try going down to 95,000. It goes up. Well, okay, that sounds pretty good. We could even go down further to 90 as an example. Now let's do this a different way. Let's use the solver in Excel. So I'm going to go over here to Data Solver. And I set this up where it's going to maximize D24. And that is the average profit based on the demand, which is shown in C9. And we want to maximize that. So let's solve that and see what answer we get. So it found an answer of 689 profit using an order quantity of 82,600. Okay. So let's put the optimum. We'll just stick that over here. We want to compare that to a couple of other ways of doing this. Oh, I should have mentioned that this demand here is coming from this demand library. And over here we have and down 1,000 data points. Now, this actual demand, as you can see, is going from, well, it's coming down here about 2,500, 25,000, and goes up higher to 160,000 or something of that nature, okay? But rather than storing those 1,000 data points over the demand library, we can generate a metalog. And this metalog, if you use the generalized, turns out to be 5 terms with a lower bound of 10,000 and upper bound of 200,000. One of the nice things about the metalog is it will document your equation. That metalog demand is reflected in this model that I did previously. And here are the data points that we looked at, those 1,000 data points. And they're plotted in the yellow. And the blue line represents the solution. It shows the density function. So you can see this is pretty normal looking. At least it's symmetrical. And then down here is the equation. And this is where it shows, oh, this is showing 7 terms. Okay, we could say, change the number of terms here. Well, it says 5 here. Oh, I know why. Because to get to the right function here, we need to hit this make metalog function. So make metalog function. And now we have 5 terms. Let's see, I'll make that bit bigger. 5 terms, 10,000 and 200,000 using our 1,000 data points. And we can see how well it fits. So what if we use that metalog? How different would the answer be? Well, we can do that by going back over here to the model. And rather than selecting the original data set, we can select the Metalog 1. We'll go through the same exercise. We'll solve that one. And now we can see that this answer here is slightly less. Whether that's significant in the big scheme of things, not sure. Oh, I'll tell you, let's do this one more thing. Let's take this average profit. We'll stick it down here, okay? And then if we want to get back to that old one, we need to come back over here to the demand, the original. We need to copy that back in over here. And then we can copy this. This is the average profit. So some difference. We can come down here and look at those 2 demand curves. We can see the metalog is, as it's calculated, is a little bit less down here. The average demand is actually higher, though, for the metalog. So let's do one more thing. Let's take that metalog distribution and change it. Instead of being so symmetrical, let's make a second metalog, which is more log normal looking. It's not actually a log more normal, it's something else. We can look at that one too. We can see that that's going to be a 5 term with 200,000, 20,000 minimum, and 70,000 maximum. And that demand curve looks like this. That red line, you can see how it's much longer here. Okay, back to the model. So we want to maximize this. So once again, we're right down here. We'll go to data, solver, and we'll solve that one. So here, maximum order quantity, much lower. And the profit, average profit, is also much lower. Now, if this is a more complicated model, or may have more variables or whatever, we might be interested in another aspect of this model. Let me unfilter this. And we can use sensitivity analysis. And here I've used sensitivity analysis to plot the order quantity versus the average profit for the Metalog 1 in blue and the Metalog 2 in red. And by visual inspection, we can get a very good idea of what the optimum value is. And that can get us reasonably close. And if I took this, if we blow this graph up, we can come down and look at this and get another visual of what's important. And this is the probability of loss. So here it's a 10% loss and around the maximum, but the difference here is somewhat small. So we might prefer to actually come down in order quantity and have a lower chance of loss. Up here, this difference between 7 and 4 is maybe a little bit larger. So I may want to go with 7% or in this range. So this is a way of making a decision of what you want to do using sensitivity and plotting basically 3 variables. Here are the order quantity, the average profit, and the probability of loss. You can learn more about the Flaw of Averages by looking at these 2 books, The Flaw of Averages, which is the original book by Sam Savage, and his newer book, The Chancification. If you'd like even more, you can visit the probabilitymanagement.org website, and you can look at my YouTube channel, where it has SIPMath applications using for cost of schedule risk analysis, portfolio analysis, value of information, and then there's some mind teasers you might find interesting. The birthday problem, let's make a deal, a frog problem, and a taxi cab problem that are kind of interesting to think about. Hope you found this video useful. Thank you.